Hello. In this video, we're going to take our understanding of quadratic relationships and apply it to word problems. So with that in mind, let's remember back to when we were doing word problems. In these older word problems typically used linear relationships, but we kind of set up a 5-step process to working through a word problem. We define our variables, we find our equations, we solve our equations, we check our answer, and then we make a statement. So let's dive into this one. The sum of two squares of two consecutive odd integers is 290. Find the integers. So the first step here is I'm going to say let x represent an integer we're going to say let y represent an integer. So there's our let statement. So now I'm going to set up my equation. So it says the sum of the squares of two consecutive odd integers is 290. And what that means is x squared plus y squared is equal to 290. So there's my first equation. We'll call that equation 1. And if there are two consecutive odd integers, and again, one strategy when you're doing word problems is to get out a highlighter. Two consecutive odd integers. Okay, that will help me remember what I'm doing. If only I could show you some of my tests when I was younger. There's a lot of highlighter on that page. So, moving on. So if there are two consecutive odd integers, it means there are two odd integers that are in a row. So we know odd integers, if we take, for example, an odd integer 3, the next one would be 5. So that's going to take, let's say, that means that x plus 2 is equal to y. So this tells me that I'm stating that x is the smaller of the two odd integers. So now, let's call that 2. So we'll sub 2 into 1. And so we'll do this, x squared plus bracket x plus 2 squared is equal to 290. So now I'm going to expand this because I recognize I have a quadratic here in some form, and let's expand this out so we can get a better look at it. So we expand this binomial, we get x squared plus 4x plus 4 equals 290. If you're having trouble, let's just change colors here for a second. If you're having trouble with this expansion, be sure to go and practice that. If I come over here really quickly, let me just do that quickly. X plus 2 squared is equal to x plus 2 times x plus 2. So x and x gives me x squared. X times 2 gives me 2x. 2 and x gives me 2x. 2 and 2 gives me 4. So we get x squared plus 4x plus 4. Ideally, we want to be able to do this in one step, but if you have to take a moment and do that expansion, that's okay. So now I'm going to rearrange this equation. Because I see I have a quadratic here, I'm going to group like terms. So we see we have 2x squared plus 4x plus 4 equals 290. And of course, with a quadratic, we get our special form, we called it, where we have our quadratic equal to 0. And so we say minus 286, and that is equal to 0. So we're going to try and factor this now, and of course, you could factor this. However, what we always want to try and do is common factor first. We can factor a 2 out of this. And if I divide both sides by 2, I get x squared plus 2x minus 143 equals 0. So now I'm going to factor this, and to do this, I notice this is x squared, so it has to be x and x. And there's lots of different ways to approach this. Often what I do in these types of problems, since I know the answer has to be an integer, I know they're going to be nice numbers, so I can probably guess this. I'm looking for two numbers that multiply to give me negative 143, but add to give me 2. What gets me really excited about this specific case here is that if I look at the number 143, I see 1 plus 3 is 4. And that makes me think of a little trick when multiplying by 11s. Let's just do this quickly. If you're taking a 2-digit number, so say 13 times 11, when you multiply by 11, you can actually split that value, add the digits, and there you go. So since the sum of the middle number is the sum of the two other values, I know it's divisible by 11. So that's a long way of saying I'm going to take my calculator and divide it by 11. And look at that, I get 13. So therefore, I can say x plus 13, x minus 11. And therefore now we can say x can equal negative 13, or x can equal to 11. These are our two cases. With these types of problems, we'll often get two cases. So at this point, you always want to stop and ask yourself, do both cases make sense? You will end up in situations where one case doesn't make sense. Those situations are often when you're working with time, because time, if we think of time as t, it has to be greater than or equal to 0. Or we might be dealing with a length. A length has to be greater than or equal to 0. Okay, so that's what I mean by asking yourself if it makes sense. I see that negative 13 and 11 are both odd integers, so they are both valid. Okay, so now that's only one of the values, so what I now do is I take my work and I break it up and I say, okay, let's continue working with case 1. And case 1 is when x is equal to negative 13. If x is equal to negative 13, we can sub x into 2, and we get y is equal to negative 11. And now I can do a check. So I'm going to use equation 1 to check. You only have to check in one equation. Okay, and so if I work this out, 13 squared is 169. Sorry, negative 13 squared is 169. Negative 11 squared is 121. If we add those together, I see that 290 is in fact equal to 290. So I know that case 1 is valid. And if I want to feel good about this, I just come out here and put a little check mark. So now we're going to look at case 2. So if x is equal to 11, we're going to sub x into 2. So we see that y ends up being 13. So therefore, we'll do a check. So we end up with 11 squared plus 13 squared equals 290. And with a little bit of math, we can show that 290 is equal to 290. And that means that's valid too. So now you can say, therefore, the numbers are negative 13, negative 11, or 11 and 13. And we're done. So this is an example of a word problem that uses our understanding of quadratic relationships. Remember to use that 5-step process. And remember, with these types of problems, we're going to start seeing more and more cases come up where one answer might not make sense. So be sure you watch for that. And always ask yourself, does my answer make sense? I hope this video helped.